in this part, we want to talk about nonlinear inequalities. And we have already know how to solve a linear inequality. Linear inequality like this one, which is the, for example, 3x minus 5 greater than 0, right? So we add 5 on both sides, then divide by 3, then you will have x is greater than 5 over 3, and the interval notation is 5 over 3 to positive infinity, right? So this is the linear inequality we already know. So now, why we call it linear inequality? Because the power of x is 1 here. So now we are looking at the inequalities with the power of x is greater than 1. It's called nonlinear inequalities. So we use example to illustrate how to solve this kind of inequalities. Let's look at this example. This is the x squared minus 2x minus 3 is less than 0. Okay, so the first thing is step 1, which is we needed to factorize. Okay, we factorize in the real number system, So we don't need to consider the complex number system. So we factorize the left side. Okay, so x squared minus 2x minus 3, which is equal to x minus 3 and x plus 1. Okay, so now the step 2 is we need to find all real zeros. This is called the key numbers of the inequalities. Find the real zero or rational zero. This is called the key numbers. Okay, so here one thing I should mention is that we always want to keep the right side to be 0. Okay, so this one, the real zero for this one is, this is, for example, if we let this one to be f of x, we find the real zeros of f. So this is the x equals 3 and x equals -1. Okay, so now the step 3 is we need to locate these real zeros on the number line, x-axis. Okay, x-axis. So since here is less than, there is not equal to 0. Okay, there's no equal 0, so it's less than, so we just locate these two real zeros, but with a hollowed circle. So that means this point cannot be included, and this point cannot be included. So this is okay. So we have these two key numbers or real zeros. Divide our interval from -infinity to infinity into what? Into 3 parts. Right, this part is -infinity to -1. And this part is -1 to 3. And this part is 3 to positive infinity. Then what we need to do is, so this is called the test intervals. Then the next step is we need to determine the function f, the sign of the function f on each test intervals by evaluating any specific numbers. So we need to determine the sign of this function fx. This f is just the left side of this inequality for each interval, each test interval actually, by evaluating a representative value, x value in this interval, test interval. Okay, so what does this mean? This means for example, on this interval from -infinity to -1, we just pick arbitrary x values in this interval. We pick, for example, x equals -2. So then we evaluate f of -2. F of -2 becomes what? -2 squared minus 2 times the f of x is this one, right? Minus 2 times x minus 3. So actually this is equal to 5, which is greater than 0. So on this interval, it should be positive. Right? This interval is positive. On this interval, from -1 to 3, we just pick arbitrary 1. We pick x equals 0. So we always pick some numbers. It's easy to calculate, right? X equals 0. So it's the 0 squared minus 2 times 0 minus 3. This is -3, which is less than 0. So on this interval, this function should be less than 0. Okay, on this interval, this function, we pick arbitrary number. We pick, for example, 4. Okay, so this is the f of 4, which is 4 squared minus 2 times 4 minus 3. Obviously, it's greater than 0, right? We don't need to calculate exact number. We just need to know it's positive or negative. So on this interval, it's positive. So here tells you that what is our aim? We need, which is less than 0. So less than 0 is negative. So here is the 1. So our function x squared minus 2x minus 3 less than 0. The solution is x is between greater than -1, less than 3. Okay, so this is the one way to solve the linear nonlinear inequalities. We should make the right side of the inequality to be 0, then let the left side to be f of x. So we factorize this f of x, then find the real zeros, which we call the key numbers, and locate these key numbers on the number line. So here, circle or solid circle, depending on this, the inequality is if the inequality contains equal sign or not. Okay, if it does not contain equal sign, we should have a hollow circle. That means these points cannot be included. So the end point is not included. So if it's equal sign, we should have some solid circle. So that means this point is included. So these two key numbers divide our interval into several parts. Then for each part, we just pick arbitrary number in each interval. Then to test the function value, is positive or negative. If it's positive, we say, okay, on this interval, it has a positive. All the function values are positive. If it's negative, then we say, okay, on this interval, all the function values are negative. Then we need to determine the result. So here in this example, we need less than 0, which is negative. So there is only one interval, which is f of x is negative when x between -1 to 3. So this is the one way to solve this inequalities. But of course, there are many other ways. Let's look at a method 2. Okay. So this method is not mentioned in the textbook, but here I also want you to know that we can use the graph. Okay, we can sketch the graph because the left side is a polynomial, right? The polynomial, we can always sketch the graph. Graph method. Okay, so our f of x, so we still need to look at this inequalities, right? So we let the left side to be f of x equals x squared minus 2x minus 3, right? So we have what? We need to end behavior, which is y equals x squared, right? Y equals x squared looks like this one. This is the end behavior. And then we have the zeros, real zeros. We just need to know which is x squared minus equals 0. So this is the x minus 3. X plus 1 equals 0, so we have x equals 3, x equals -1, right? So the graph will be, and the multiplicity, so the multiplicity of 3 equals 1, and the multiplicity of -1 equals 1. So that means the curve will cross the point, right? So this is -1, and this is 3, right? So the behavior would be this one, right? This is the behavior. Okay, so the end behavior, so this will cross this part and cross this part. So this is our graph. And from the graph, we know if greater than less than -1, the function is positive here, right? Between -1 and 3, the curve is below x-axis. So that means this part is negative and here is positive. So what we want negative, right? We want negative. So these 2 points should not be included because at these 2 points they are equal to 0, right? So we have x is between -1 to 3. So you can use the graph also to help you to solve the problem. Okay, so this is called the graph method. So now let's look at more examples. You have 2x cubed minus 3x squared minus 32x is greater than or equal to -48. Okay, so now we need to make the right side to be 0. So we add 48 on both sides. So the next thing is we need to factorize, okay? So we need to let, okay, what's the first thing? We need to let f of x equals the left side, which is 2x cubed minus 3x squared minus 32x plus 48. Okay? So here is we want to factorize what we should do. There are many ways, right? one way is just use the calculation technique to factorize directly. If you're not familiar with that, let's think about, do you remember how to find the zeros for the polynomial function? We needed to find the rational zeros first, right? And we also needed to find the using the rational zeros, so we plug in the possible rational zeros to see if you can find one rational zero, then you can use the long division, right? Use the long division to reduce the power. Then it becomes from the third degree to second degree. Then for the second degree, then you can factorize directly, right? So this is a very long story. We have studied in the previous section. You can go back to review that part, but here I want to tell you another one. We can do this one directly. Okay, we can factorize it directly. So now let's look at, let's combine the first two terms. So it's the x squared, which is 2x minus 3, right? Minus, let's take 16, this is the common factor of these two. So let's take negative 16. So this is 2x minus 3, right? So you can see we have this common factor 2x minus 3 times x squared minus 16. And this is the 2x minus 3 times x minus 4, x plus 4. Okay, so now our inequality becomes 2x minus 3, x minus 4, x plus 4 greater than equal to 0. This is our inequality, right? So we have the real zeros or key numbers, which is x equals, which is real zeros for the left side, right? So this one is x equals 3 over 2, x equals 4, x equals negative 4, right? So these are key numbers. So we locate these key numbers on our number line. Okay, so this is the 3 over 2. So since it contains an equal sign, right? Greater than equal to. So we use the solid point. So that means this point should be included if this interval will be our aim. Okay, and then this is the negative 4. And here is 4. Then on each interval, so we have different intervals, right? We have negative infinity to negative 4. This is the negative 4 and the 3 over 2. And this is the 3 over 2 to 4. And this is 4 to positive infinity, right? So one of us, then we needed to test the sign, right, on each test intervals. So on this interval from negative infinity to negative 4, we just choose x to be, for example, negative 5. Okay, so we plug in this one. This is easy, right? So our f of negative 5 is equal to 2 times negative 5 minus 3. Negative 5 minus 4 times negative 5 plus 4. Okay, so if you use a calculator, it's equal to negative 117. So it's negative less than 0. So on this interval, it's a negative sign. Okay, and on this interval from negative 4 to 3 over 2, we can pick x equals 0. So you can pick an arbitrary number. You can pick x equals negative 3, right? But we notice that 0 is much convenient, right? So you plug in f of 0, plug in 0 to f, so it's actually equal to 48. What is f? F is this one, right? You can write this one or this one. Doesn't matter which one is convenient for you. Right, this is greater than 0. So this is positive on this interval. And on this interval, 3 over 2 to 4, we just pick after you can pick x equals 3 or x equals 2, right? So here we just pick x equals 2 f of 2. If you use a calculator, it would be negative 12. You can check. It's less than 0, so it's minus. And this is 4 to positive infinity, right? We can take x equals 5. You can also pick x equals 6. It doesn't matter. We just needed to know it's positive or negative. If you plug in, it would be greater than 0. So here is positive. So our aim is greater than or equal to 0. So we always choose the positive part. So our solution is negative 4 to 3 over 2 union 4 to positive infinity. Or you can write as x is greater than or equal to negative 4 less than or equal to 3 over 2, or x is greater than or equal to 4. Okay. Of course, you can use the graph method. Let's write down the graph method. So no matter which method you will use, you always need what? Need to find the zeros, right? So these steps are always the same. These steps are always the same, okay? The only difference is using the graphing method, you don't need to find the test value because we just sketch the graph. We know from the graph which part is positive. Above, x-axis positive, below x-axis would be negative, right, if the curve. Okay, so we still have this, right? We still have x equals negative 4, x equals 3 over 2, and x equals 4, right? And the multiplicity of negative 4, which is 1. The multiplicity of 3 over 2 is 1. The multiplicity of 4 is 1. So every time when the curve meets the zeros, then you will cross that point, right? So you will have locate negative 4, 3 over 2, and 4. Okay, so we also need to determine the behavior, right? And the behavior. Where I write here, and the behavior. And the behavior is determined by the leading term, the highest power term, which is 2x cubed, right? And the behavior is like 2xy equal 2x cubed. 2x cubed would be this one, right? So the graph, the end behavior would be here. This one would be this one, right? So now let's connect. So we will cross to here. So here is negative because the curve is below x-axis. Here is positive, here is negative, here is positive. Our aim is what? Greater than equal to 0. Greater than equal to 0. So we need this part and this part. So our solution is negative 4 and 3 over 2 because they are equal to. So at this point, these 2 points equal 0. So it should be included, right? Union from 4 to positive infinity. Okay, so these are the inequalities, nonlinear inequality, which is actually the left side is a polynomial. Okay, is a polynomial. So now let's look at some inequality, which is the rational inequalities. The rational inequalities, the steps are very similar to the polynomial inequality, except the domain. Because when we have the rational, the domain cannot be, the denominator cannot be 0. So we should exclude the 0 points, the zeros from the denominator. Okay, so here is the one thing. If we have 2x minus 7 over x minus 5 is less than or equal to 3. Okay, so we needed to make the right side to be 0, so we subtract 3 on both sides. This is every time we needed to do that. Okay, then we combine the terms. So this is 2x minus 7 minus 3 times x minus 5, right? So what's this? This is the negative x plus 8 over x minus 5 less than 0. So we let the left side f of x to be negative x plus 8 over x minus 5, right? Okay, so we needed to find, so here the key numbers is the zeros for the numerator and the zeros from the denominator. So key numbers is what? The zeros from the numerator is x equals 8, right? The zeros from the denominator is x equals 5, right? So we needed to locate these numbers. We needed to locate things. The first thing is x equals 5 in the denominator. So it's not in the domain. So 5 must be a circle here. Okay? If 8 is here, so 8 is circle or not, it depending on this inequalities. This inequality is less than or equal to. So it could be 0. So this point should be included. Okay. So keep in mind, if the key numbers from the denominator, it always be circle. The key numbers from the numerator, you needed to go back to see the inequalities. If the inequality contains the equal sign, it should be a solid circle. Otherwise, it should be a hollowed circle. Then we have these 3 intervals, right? This interval is what? Is from negative infinity to 5. This is 5 to 8. And this is 8 to positive infinity. You can see I have the bracket next to the 8, right? Then on each interval, we needed to test a number. So here we have x equals, we pick x equals 0, for example, less than 5, right? So f of 0, if you calculate, it would be negative 8 over 5, which is less than 0. So on this interval, it's minus. On this interval, we pick x equals 6. So if you plug in f of 6, which is equal to 2, right, plug in here, right? So it's greater than 0, so it's plus here. Here is x equals 9. If you plug in f of 9, it's equal to negative 1/4, so this is less than 0. So here is negative. Okay, so now our problem is less than or equal to 0, so we need this part and this part, right? So our solution is negative infinity to 5 union 8 to positive infinity. So this 8 is included because when equals 8, it's equal to 0. So this is very similar, right? Except the only difference is if the key number is the zeros from the denominator, it will always be a circle, hollowed circle. Okay? Not like the polynomial inequality. The polynomial inequalities, it's a circle or not a circle depending on the sign. The inequality sign include equal sign or not, right? So this is the rational. So some students may ask, do we have the graphing way to solve this one? Of course, we can use the graph, right? Finding the vertical asymptote, horizontal asymptote, right? We can sketch the graph. We have learned how to do that, right, in the previous section. But you know that if you draw a graph of the rational functions, sometimes it's not convenient, not like the polynomials, right? You can just look at the end behavior, then we start to draw the graph, right? Quickly. But there is another way, which is not mentioned in our textbook, but I still want to introduce here, which is similar to the graphing method. We also call it graphing method, but instead of considering negative x plus 8 over x minus 5, we're considering this one. We consider negative x plus 8 times x minus 5. Okay, why we do that? Because we know this one is easy, this polynomial, it's easy to draw the graph, right? We don't need to find vertical asymptote, oblique asymptote, and horizontal asymptote, right? It's easy to draw the graph. Why these two should have a very similar result? The reason is, since it's an inequality, it's greater than 0 or less than 0, right? The problem becomes greater than 0 or less than 0. So we divide a number and multiply a number, it will not change the sign, right? If you divide a negative number, it's always the same as multiply a negative number, right? It's positive or negative, it doesn't change, right? If you divide a positive number, the sign should be the same as you multiply by a positive number, right? So this will give you an idea that you can, instead of looking at the graph for the rational function, we can look at the graph for the polynomial, right? So the same thing. The only difference is x cannot be 5, right? When we consider this one, we still keep in mind that the domain is x not equal to 5. So 5 is always be a circle, and 8 is a solid circle. Okay, so now let's look at this end behavior. This end behavior, okay, end behavior. And behavior is like x, if you expand the highest power term is negative x squared, right? Which is this one, right? So it should be this one and this one. And the multiplicity is 1, right? multiplicity, M8 is 1. M of 5 is 1. So you have cross, cross. So this part is negative, this part is positive, this part is negative. So what we are looking for? We are looking for less than equal to 0. Less than equal to 0. So the endpoint should be included, right? So this part and this part. So it's negative infinity to 5. 5 is not included. Union 8, when equals 8 equal to 0. So 8 should be included. So you can see we still get the same answer as the first method, right? Of course, this method 2 is optional. It just gives you some ideas. But if you are not familiar with the method, graphing method, it's okay. You just use this method, the standard method in our textbook, which is test numbers, test intervals.